Welcome to this tutorial on NumPy's mean function. The mean, also known as the average, is one of the most commonly used statistical measures in data analysis. NumPy provides a simple and efficient way to calculate means using the np.mean function. This function works with arrays of any dimension and provides flexible options for computing averages along specific axes. Before diving into the code, let's understand what the mean actually represents. The mean is the arithmetic average of a set of numbers. To calculate it, you add up all the values in your dataset and then divide by the total number of values. For example, if you have the numbers 10, 20, and 30, you would add them to get 60, then divide by 3 to get a mean of 20. This gives you a central value that represents your entire dataset. The syntax for NumPy's mean function is straightforward. You call np.mean and pass your array as the argument. This is the most basic form of the function, and it will calculate the mean of all elements in the array, regardless of its shape or dimensions. The function returns a single floating point number representing the average of all values. Let's look at a practical example with a one-dimensional array. First, we import NumPy as np, then we create an array containing the values 10, 20, 30, 40, and 50. When we call np.mean on this array, NumPy adds all 5 numbers together to get 150, then divides by 5 to get 30.0. The result is returned as a floating point number, which is why we see 30.0 instead of just 30. When working with two-dimensional arrays, the default behavior is to calculate the mean of all elements flattened into a single sequence. In this example, we have a 2x3 array with values from 1 to 6. Without specifying an axis parameter, np.mean treats all 6 numbers equally, adding them up to get 21, then dividing by 6 to get 3.5. This gives us the overall average across the entire array. To gain more control over how the mean is calculated in multidimensional arrays, NumPy provides the axis parameter. By default, the axis parameter is set to none, which means the mean is calculated across all elements. However, you can specify a particular axis to calculate means along specific dimensions of your array. This is especially useful when working with datasets organized in rows and columns. When you set axis equals 0, NumPy calculates the mean along the columns, which means it computes averages going down each column. Using our 2x3 array as an example, NumPy calculates 3 separate means, one for each column. The first column contains 1 and 4, which average to 2.5. The second column contains 2 and 5, averaging to 3.5. The third column contains 3 and 6, averaging to 4.5. The result is a one-dimensional array with 3 values. Conversely, when you set axis equals 1, NumPy calculates the mean along the rows, which means it computes averages going across each row. In our example array, the first row contains 1, 2, and 3, which average to 2.0. The second row contains 4, 5, and 6, which average to 5.0. This returns a one-dimensional array with 2 values, one for each row. Understanding how to use the axis parameter gives you powerful control over your data analysis workflows.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.